My name is Mike Morley and I'm the geoarchaeologist on the site. And geoarchaeology is a discipline that straddles geography, archaeology and geology. My role on the site is to understand how the site has formed through time, how the layers have been deposited, how the archaeology has been preserved at the site, and how changes through time relate to changes in the environment outside of the site and humans and their role inside of the site. So it's just really getting an understanding of why this site is here, what processes have occurred to actually form this site. This is quite an interesting area of the site because we have a number of layers in here that we can correlate across to layers that we see in the main pit over there where Floresiensis remains were found. Layers like these volcanic ash layers are quite interesting because they also show very different changes in sedimentary deposition. So we have volcanic ash layers in here, so we have volcanic events, we have points where there's been a break in deposition. So at some point in the past this was a former ground surface of the shelter, and there's a number of these flow stones that show that there's periods where the sediment has stopped being deposited on the site. So my job really is to understand how did these layers form and what's happened to them since they were deposited. So here we have a schematic cartoon, if you like, of the different depositional environments that we see at Liangbur. So if we take the first one, the sediments that we see at the base of the sequence were actually deposited by a river when the river actually inundated the site and brought in sediment from outside the site. And this happened around about 190,000 years ago. If we move to the second slide, we can see that we have a truncation rather than the river flowing in through the front. We have water coming in from the rear of the cave through cracks and fissures. That's bringing sediment down from the back of the cave, and essentially because the river has downcut into its floodplain and has now moved away from the site, water travelling from the back of the cave and leaving the site is travelling downslope, and it's actually planing off those river sediments. That process we actually call colluviation. So if we move to the third slide then, we can see that we now have the river sediments at the base with this angled surface upon which we have these colluvial sediments sitting on top. So sometime between 50 and 47,000 years ago, a volcano has erupted in the vicinity of the site, and during this time, clouds of billowing ash coming down into the valley have blown into Liangbur, and they've covered all of the sediments. So moving on to the fourth slide then, again we have water that's percolating down from the rear of the cave through cracks and fissures, bringing down these fine-grained sediments, and those sediments are largely comprised of silts and clays, very fine-grained materials. So those fine-grained sediments are actually now covering that volcanic ash. So if we move on to the fifth slide, the catchment area or the region in which Liangbur is situated is becoming drier. The main signal we see, in fact, from the sediments is that the roof and the walls of the cave are actually breaking down, and little chunks of limestone and speleothem, or stalactites and stalagmites, are breaking off the wall and the roof of the cave. So the sediments are much more coarse-grained at this point. And this drier period also happens to coincide with hominins using the cave, because we see evidence of fire, and this time the fire isn't from volcanic activity. We're not talking about ash from volcanoes, we're talking about ash from the combustion of wood and leaves and other plant materials. So if we move on to layer 6, you can see that we have those new layers there. We can see the yellow layer of the kind of gravels and the material that's broken off the walls and the roof of the cave, with these episodic burning episodes contained within that. So now we're getting renewed water flow from the rear of the cave, and this water flow ends up forming what we call a flow stone. It's a bit like a stalactite or a stalagmite. It's made of solid calcium carbonate. So if we move on to slide number 7, we have evidence of bats roosting in the cave. And when bats roost in a cave, they produce lots of bat droppings. Lots of bat droppings can form very thick layers of what we call guano. The flowstone, as we see it today, has been very heavily chemically modified. Water is percolated down through the guano, and in doing so, the water becomes quite acid loaded, and it's actually leached the calcium carbonate out of the flowstone beneath and changed it into another mineral form. We can see that optically under the microscope and also using other geochemical techniques. Now if we move on to number 8, we see again there's this kind of switching on of the tap at the back of the cave, so we're getting more of this colluviation of fine-grained sediments as they get washed down from the rear of the site. And we think during this time, as the fine-grained sediments are washed down, that the kind of erosive action of that has washed any evidence of that guano away. So we can see then in the last picture, which takes us right up to modern times, you can see the whole sequence there. You can see the river sediments at the base, sometime around 190,000 years ago. Then we have the fine-grained colluviation, somewhere between 190 and 50. We can't constrain it any closer than that. Then we have that red layer, which is the volcanic eruption. And then we have some more fine-grained colluviation. Then we have the period where it's much drier at the site, and we have hominin activity somewhere around 41 to 33,000 years ago. And then we have switch back to this laminar flow. We have these flowstones being formed around 24,000 years ago. And then we have the bat droppings and the stabilization of the site before fine-grained colluviation. All of this occurring sometime over the last 24,000 years, bringing us right up to the modern times.